Hello, everyone. Welcome to another Algebra and Trigonometry with Professor V. So, we're still in Chapter 1. We are starting to get into Section 2. Section 2 is about exponents and scientific notation. So, we're starting off with exponents. So, let's go ahead and start. So, I have all my different rules here. Okay, there's the product rule. A to the m times a to the n is equal to a m plus n. And this idea really does come from, like, let's say 3 squared, right? Times 3 to the 3, right? So what we would get here is 9 times 27. And then 9 times 27 would be 63, right? So carry the 6. So that's 18, 19, 20, 21, 22, 23, 24. So that should be 243, okay? But, right, why are we allowed to add these, right? Well, let's break it down, right? 3 squared is 3 times 3, right? And then 3 cubed is just, so this times, right? I'm going to put it as a dot to represent that's the times. 3 times 3 times 3, right? So here we're still going to get the 9, right? And this one will still get 27. And we'll still get 243. So, if we collect all these terms, right? 3 times 3 times 3 times 3 times 3, that ends up being 3 to the 5th power, okay? So that's why this first product rule works out the way it does, okay? Now, the next one to view is the quotient rule, right? So let's say we had something like 3 to the 3rd over 3 to the 2nd, right? This rule states that we can take the top exponent. Oh man, these threes are so horrible. Why did I choose threes? And we can minus the bottom one. So we end up with 3 to the 1st power, which is just 3, right? But, so why does this work, right? So this ends up being 9 over 6, right? Or did I do something? Sorry. 3 to the 3rd power is 27, right? 3 to the 2nd power is 9. So how many 9s fit into 27? 3 of them, right? So these rules, they're foundational, right? We can definitely prove these real quick to you. Hopefully this doesn't make the video too long, but it is what it is, right? So the power of a power rule states that if you have a power on the inside, right, like 3 squared, and then everything's cubed. Well, what that means, right, is you have 3 squared times 3 squared times 3 squared, right? But we already looked at this rule, right? If we're timesing and they're the same base, right? So the base is the 3, right? 3 is our base. We just add the exponents. So it's 3, 2 plus 2 plus 2, right? So that's 3 to the 6th power. I'm not going to do that. That's some number, right? But do look at that, right? What they're stating with this rule is take the inside power times it by the outside power, and you get 3 to the 6th, okay? So that's the power rule. Now the zero exponent rule is a fun one. I had a 6th grade teacher ask me a couple years ago, why is something to the 0 power 1, right? Well, let's say we have 3 squared over 3 squared, right? That's 9 over 9, which is just 1, right? But according to the rule, right, we should say 3. So we're using the quotient rule here, right? We're going to take the first power, the top power, and subtract the power that's in the denominator. They have the same base, so we end up with 3 to the 0. And since this is 3 to the 0, but it also equals 1, right? It is equal to 1. So there's a little proof right there. Now this one, the negative rule, so I didn't copy the instructions to save some space, but they want every exponent written as positive. So the negative rule states if we have 3 to the negative 2, you can use the reciprocal. So fancy way of saying flip, right? Flip your fraction. You end up with 3 squared, so you end up with 1 over 9, okay? So this is how we'll handle the negative rule. Now the power of a product rule, let's see. The power of a product rule and the power of a quotient rule are essentially like the distribution property is how I like to see them, okay? Although instead of plus and minus, right, we have this a times b, or we could just denote this as ab, okay? Everything to the nth power. So it's like the distribution power, right? It's the power rule if you can see it, right? How many powers are there in your 1? So that's 1 times n, right? an. And then that's n times 1, so that's bn, okay? And then the quotient rule is very similar, right? So if we have a over b, and even if that was squared, right? That's going to be a times a on top, b times b on bottom. So that ends up being a squared over b squared. And we could probably do that with these, right? If it's a, b, everything squared, well, we could, well, I mean, it still works out the same, right? You're still going to end up with a squared b squared. So these are the rules that we need to do this. So it's already been about almost 7 minutes just explaining the rules, which is fine, you know, but I try not to make these videos too long. So let's see how many of these we can knock out. They're pretty simple in my opinion, right? So if we have 9 squared, hopefully we remember that's 9 times 9. And that's just 81, okay? So 15 to the negative second power, right? We have to rewrite that as a reciprocal, so it's over 1, right? So if we reciprocate the 15 squared, oh, and notice, I didn't explain that too. Notice how when we reciprocate it, the power becomes positive, okay? So that's 15 times 15. Isn't it 255? 225? Gosh, I should remember this one, but I haven't done it in a while, so let's see. That's 25, sorry, carry the 2, 5, 6, 7. That'll be 5 and 1. So it's 5, yeah, 12, carry the 1, so 225. So this will be 1 over 225. Oops, I'm on the wrong screen. There we go. So 1 over 255, 225, right? So that's how we would go about 6. Now 7, let's see. So they want 3 squared times 3 cubed, right? So we can add these powers, right? This will be 3 to the 5th power. And 3 to the 5th power is going to be 3 times 3 times 3 times 3 times 3. And I think we did this earlier, right? But we could do it again. So times 9 times 9 times 3. That becomes 81 times 3. And that'll be 3, 8, 16, 24. So 243 is what we should get for number 7. I'm going to erase some of this. So if you need to copy this, you guys have the ability to pause the video. I am erasing some of this so I have room. Okay? So 243. Okay, so the next one we have 4 to the 4th power dividing by 4. So what that does look like is it could be written as a fraction, right? I'll probably pull it a little bit over here to show my proof real quick, which does equal 4 times 4 times 4 times 4, everything over 4. So what you're allowed to do is cancel 1, 4, right? You're left with 4 to the 3 on top, which is, you know, just proving the rule again, right? So if we look at the rule, so I'm going to go ahead and erase some of this, right? So this is 4. Oops, that's a horrible 4. Look at the top power, subtract the bottom power, which is 1, right? It's just to the first power. And we still get 4 to the third, right? And 4 to the third is going to be 4 times 4 times 4. So we'll get 16 times 4. What is that? 24. Carry the 2, 4, so 64. I'm going to erase again, so that way I don't run out of room. So this will equal 64. That's how we go about problem number 8. Okay, I'm going to kind of draw a box. Kind of separate these. I know it's like a jigsaw puzzle. Sorry about that, but it is what it is. Okay, so now on to number 9. So number 9 we have, maybe I could squeeze it in here. 2 squared, everything squared. Oh no, 2 squared and then raised to the negative 2. Okay, so we could go about this in different ways, right? We could square the inside. We could do the power rule right away, which is probably the best thing to do. So we have 2, right? And then it's multiply these powers, so it becomes 2 times negative 2. And yes, the integer rules still apply, so that'll be 2 to the negative 4, right? Now, according to the negative rule, we could say that's 1 over 2 to the 4th positive, right? And then what is that? So what's 2 times 2 times 2 times 2? So that's 2, 4, 8, 16, right? And if I lost you there, that's just 2 times 2 times 2 times 2. That's 4 times 4, which is 16. Okay, so that's where the 16 came from, guys. Okay, how much time do we have? Ooh, 12 minutes. Let's try to crank these out, because they're really not that bad, right? So number 10, 1, right? Hopefully you guys can see that it's 1. But if not, we'll take our time. We'll do it. So the order of operations still exists, guys. So we would do 5 minus 8, negative 3 to the 0 power. So that's just 1, according to our 0 exponential rule. So next we have 11 thirds over 11 fourths. Yes, I'm writing it as a fraction right away. So here we would have 11, 3 minus 4, okay? So that ends up being 11 to the negative 1, right? Which ends up being 1 over positive 11. Not to the first power, but, you know, it doesn't, we imply the first power, right? So anyway. Okay, so that's these ones. I'm going to go ahead and box this in too. Okay, so the next one, it looks like 6 to the 5th power times 6 to the negative 7th. So what we have here, right, is 6, 5 plus negative 7, right? We could also flip this, so if one of you is saying, oh, this is 6/5 over 6/7, yes, you are absolutely right. If you can't see that, that's fine. We can just simply add these, so we end up with 6 to the negative 2, right? Which means that that will be downstairs, so that's in the denominator positively. And then that's 1 over 36. Okay. So the next one we have is 8 to the 0 power. Everything raised by 2. Well, according to the power rule, we take what's inside, multiply it by the outside. So that ends up being 8 to the 0, right? Which is 1. Or it could be 1 squared, which is 1 times 1, 1, right? So there's a few ways we could go about these exponents. Alright, and then the last one, so let's see what they gave us. So they gave us 5 to the negative 2 over 5 to the positive 2. Now again, we could just do the rule, right? We could take the top one, subtract it by the bottom. We end up with 5 to the negative 4, right? And that'll be 1 over 5 to the positive 4. Make sure I didn't do anything silly. Nope, nope. Alright. And that's going to be 25 times 25, right? Because that's 5 times 5 times 5 times 5. Let me kind of cut this off. So it's 25 times 25, which I should know off the top of my head too, but it's been a while since I've worked with some of these roots. Well, not even roots, squares. So 25, carry the 2. 10, 11, 12. 10, carry the 1, 4, 5. So 625. I knew it. But not 625, right? 1 over 625. So that's the exponent rules in a nutshell, you guys. I hope this video brought some value to you. It ended up being really long explaining the rules along with the math, but I think it was needed. So like and subscribe so that way you guys get updates of all the new videos. Comment down below if something was a little bit tricky, a little bit too fast. I feel like I did some of the math too fast, but it is what it is, you guys. If you need more examples, comment down below. So other than that, I hope everyone has a great day, and I will see you in the next video.